of years have been beneficiary of the cyber training grants, and there have been summer training workshops steadily from 2018 onward. So there is in fact one coming up this summer as well. UMass, Maryland, and Tennessee Tech, they have taken the lead. And typically there is a stipend, roughly $5,000 per proposal or per participant. And you get the training, as well as you develop some adoption plan. And then of course, we love to know how things are going and how the cohort actually can help. There are a couple of things that we have done so far in terms of where you can contribute or you can benefit from. So one is, of course, the courseware website. I actually had a chat message for all of the folks who talked about their projects in the previous session. We'd love to have those contributed here, at least the links, so people can find. So there's a variety of things that you can contribute, and these can be categorized, slides and modules and tools and things like that. And also you can tag them with courses, suitable topics, and this is a work in progress. That's something that we'll be continuing to work on. There are additional resources. One is the book series that Eric Saul referred to. There are 2 volumes of these books that have been contributed by the community. These have been edited textbooks and have been quite widely used. There are over 40,000 downloads by now. And we are planning on the 3rd volume about experience of adopters, those who have been actually teaching, exemplars and resources on courses and topics, kind of things that throughout the day we have looked at. That would be a book toward that kind of contribution. We also have updated the Cedar heterogeneous cluster now with Hadoop and Spark. So it's available for those who are trying to teach any class which needs parallel computing resources. You can ask for accounts, just send me an email. And for EduPar workshop and other sister workshops, and for others who are producing intellectual contributions, we have this JPDC special issue series. So now, in fact, we are working on the 3rd one right now, and that should be coming out pretty soon this summer. So the version 2 activities, it was organized along these aspects of exemplars, distributed computing, big data, energy, and pervasive. And this table shows, these slides are, by the way, posted, or they will get posted. And then they have been led also. And then also we have these verticals, the areas, architecture, algorithms, and programming. So it has been a community effort, and many other folks also have been helping contribute as well as review these. The timeline is we released the beta version last November during the supercomputing. And so we are going through this public feedback phase, and we do want critical help there. By summer, we would like to finalize this and then formalize that into version 2. There are other companion activities that have also started with this new grants from NSF. So to look at exemplar activities, creating those, and also collecting those. So if you have things to contribute there, we also would have a working group to look at the TCP curriculum in the context of especially the computer engineering aspects. And of course, we are also going to be thinking about competency-based versions, what needs to be done to go from what we have right now toward that. So knowledge, skills, and attitudes. On the side, we have another project going on that is to plan for an institute. So really going to the next level, what it will take to really turn the tide. We have a lot of momentum. You can see lots of projects, how we can collaborate. So we have had 4 such workshops already conducted, last 3 online. And the next one is going to be early fall to report back to NSF. And definitely that's another area to to help out if you're interested. Let me now call on my colleagues to go through those areas. So pervasive and emerging topics, Vadi will help us here. Hey, Vadi.
Thank you, Sushil. Good afternoon, everybody. I assume it's afternoon wherever you are, or early evening, maybe. My name is Vaidyanathan. And so one of the major changes that was made since the 2012 update was looking at what was then called the cross-cutting topics. And and looking at it in a slightly more fine-grained way. And we have two aspects to that. One is the pervasive topics, and the second one is the emerging topics. Pervasive topics, which I'll talk about a little bit more detail in the next slide, but basically these are the fundamental ones which, and not a surprise that they were cross-cutting. They threaded themselves through all manners of other aspects of computing. And the emerging topics, which are more short-term in the sense that they are the ones of more current interest. And both of these provide very unique opportunities for us in terms of the curriculum. The emerging topics in particular would be those in the context of which, with which as a backdrop, you would have the ear of many students. It's much easier to talk to students in terms of, let's say, maybe deep learning rather than asynchrony. So they provide unique opportunities which are very different from other situations where you may be able to even use perhaps not so technical examples to underline some important ideas. Next slide, please. So the pervasive topics, these are fundamental topics which we expect to stay around for a long time. They have been around for a long time. And sometimes you may even say that they transcend PDC and perhaps even some elements of computing. So the idea is that these sort of topics should be taught right from the beginning so that the foundational aspects of these fundamental topics are set up pretty early on before they move into specifics of computing, specifics of algorithms, languages, et cetera, And along these lines, again, before I go ahead with this is work in progress. We have identified 4 very broad, very, very broad things under this umbrella in the context of PDC, of course. They are asynchrony, concurrency and sequential dependency, locality, and performance. This is by no means exhaustive. And as I said, we are using a very broad umbrella with these terms. For example, locality is not just with respect to memory references. It could be spatial locality, which, in the context of distributed computing. So they are not strict compartments, and they clearly, impact each other. Next slide, please, Sushil. So here's a small example of, we pulled out a couple of things from the pervasive topics table. In asynchrony, the basic idea is for students as they move through the entire curriculum is to understand the cause effect of asynchrony, maybe, what can be the advantages of asynchrony and the deleterious effects of asynchrony. They can cause errors, raise conditions. And similarly in concurrency, from a very fundamental point of view, again, I'm saying these things in generality because they will actually harden and form a more concrete shape as as you progress through the curriculum. But the point that we want to make is that this is a continuous thread that goes through the entire curriculum, as opposed to you are familiar with the term. We feel that these topics are sufficiently important to the basic nature of computing itself today that they should go through as a continuous thread. Next slide, please.
Go ahead, Paddy.
Next. Oh, yeah. Okay. There was a little lag. I'm sorry. So again, these are listing some of the topics that are of current interest. I mean, there are clearly other things that could be there, IoT, et cetera, but the point is, again, to use these as leverage to be able to talk about something that students may already be familiar with. And certainly, most of the details are most likely going to be covered in more advanced courses. Networking, for example, doesn't have to be advanced, but some of the others, like machine learning itself, or some aspects of quantum computing, etc., may be in advanced courses. But nevertheless, they still provide us with the opportunity to reveal a whole bunch of things about PDC in a manner that would be have a captive audience in a manner of speaking. Thanks.
Alan?
Oh, yeah, I guess it's my turn. So I guess I'm going to talk about the programming topics, and I think this is of interest to most people because that's where most people see, most students and most faculty teach parallel distributed computing and programming topics. So the main goal of the programming topics is to introduce them into the intro courses and also into the upper level classes. And we're targeting mainly the intro programming classes, data structures, and systems classes, those introductory classes that are in the curriculum guidelines. The topics are organized into four sort of major themes. So for paradigms and notations, and you see SIMD, shared memory, message passing, things like that. Semantics and correctness, that's where you get into concurrency bugs and synchronization. Memory models, as one of our papers talked about this morning, things like sequential consistency and weak consistency for shared memory programming. And then performance and energy, where energy is a new topic. So performance gets into data decomposition, computation decomposition, data layouts, locality, and then of course also on the energy side, so power and energy related things. Most of the topics, so it's a little scary because this is also there's a pretty long set of topics listed here, but most of them are at a relatively shallow level, meaning a blue level of comprehensive or just know the topics for the intro courses, but then again, going into a deeper level for upper level advanced courses. And some of the topics don't even appear at all in the intro courses. So that would mean they're at an end bloom level for the intro courses, and the tables are organized that way if you go look at the curriculum. So next slide, please. So the big changes for this round are incorporating several new programming topics related to distributed computing, things like client server and a couple other things. Big data topics related to map-reduce programming paradigm, and a couple other things related to that, and big data topics, and then power and energy and how to program to minimize power and energy consumption. Some of the topics were also eliminated from the original guidelines completely since they're no longer relevant. Things that just have, over the last 8 or 9 years, the world has changed a bit. We added a small number of other topics that were missing in the original guidelines, or some things that were newer ideas. That the big example there is accelerator programming, which was there but not as important 9 years ago. We also did a lot of revision to the learning outcomes and the bloom levels, changing the bloom levels, and of course updating the learning outcomes to be more up to date and better organized. What we also did, the big change in terms of the overall curriculum, is we added learning outcomes and bloom levels for advanced courses sort of in a pervasive way across the entire curriculum, all the programming topics and the other topics. So looking at where things that maybe still fit into the core courses, but also have more advanced topics related to that. So there's a lot more of that in the revised curriculum. Next slide, please. We also, I think Sushil talked a little about this. We got input from a set of reviewers already as part of the initial, before even releasing the beta version. And there were suggestions to do a better job on the pervasive ideas. So you saw some of that when Vaidi talked about better definitions of terms and acronyms. The original, our first cut at the power and energy topics was actually rather deep, perhaps a little deeper than we intended to. And so there were some suggestions on keeping those higher level, especially from a programming point of view, not necessarily from an architecture point of view. And then there were suggestions that we took into account in the current version that's available for review. And I think I'll stop there and try and keep it short. So.
Thank you, Alan. Chip.
Okay, next slide. Okay, so in the architecture area, despite the fact that we saw a great keynote this morning that showed how architecture could be a core component of an early course, we recognize that most early courses are not built around architecture. And so the majority of the core topics in the curriculum show up in the systems course. And a few of them are recommended for CS1 and CS2. Mostly to explain things like threading in libraries and event handlers and GUIs. The goal is for, by the end of the second year, for all the students, though, to be aware of the hardware aspects of parallel and distributed computing that affect the kinds of algorithmic problem solving they're going to do. And we see parallel and distributed algorithms as becoming core elements of computational thinking, that this is now something that is so pervasive that it's actually should be starting to displace some of the emphasis we put on sequential algorithms. So that leaves most of the topics, unlike the programming section, for the more advanced courses. And many of those are already covered there at or beyond the suggested Bloom level. So in the Architecture 2 course, for example. Next slide. So the topics are broken down into classes of parallelism, underlying mechanisms. We still have a section on floating point representation because people tend to associate PDC with high performance computing, and so there have always been questions about if we exclude it, why it's not included, although it is not an essential element of PDC, we recognize. Then some material on performance metrics. And new in this area, all of that's been reorganized. The Bloom levels have been adjusted. The course designations have been adjusted. The recommendations have been adjusted for all of them. But the new areas that we dove into much more deeply are power and scaling. And so those end up being very significant, but of course, not until we get to those more advanced courses. So the architecture area is again focused mainly on the upper level courses, which are now covered more extensively in the curriculum guideline, and still just moderately reflected in the early courses. And that's it for the architecture side.
All right, Vaidi, you're going to also look at the algorithms.
Okay, next slide, please. So in the algorithms area also, just as in the other areas, architecture and programming, we looked at the Bloom levels and other things, readjusted many of the ideas, reconciled the levels and so on and so forth. But so what I'm going to talk about is the most extensive changes that we made, and that was into organizing the algorithm topics, which were pretty extensive, into three basic ideas. One in terms of parallel distributed models, their complexity. The second in terms of fundamental techniques in PDC that would be useful. And the third is in terms of looking at problems that recur or can provide good examples of how to understand key elements of PDC. Next slide, please. So one of the things that we introduced with respect to as a recommendation, as a very first recommendation, is to talk about a model of choice that would kind of run through the entire curriculum, because it's very difficult to talk about PDC unless you have a model on which you can explain algorithms. And our recommendation has been to choose something very simple. For example, you could choose a PRAM, where everything is free except for the native parallelism. So a completely parallel or a embarrassingly parallel algorithm would take no time, whereas there are others which are inherently limited by how much they can be parallelized, and those ideas can be brought out much easily on a PRAM type of situation. On the other hand, you could take a completely connected model to gloss over any communication ideas. I mean, PRAM also does that, but to include communication ideas without major communication latencies. So much of what we changed has to be woven around the model of choice. Next slide, please. And the other idea that we threw in there was because algorithms have so many aspects to it, all the way from the model to various implementation details that can come in. So we added in some mention of an experience that brings together a lot of ideas, a lot of algorithmic ideas, whether those are in terms of striping the data, or in terms of actually solving the problem, or in terms of the communication strategy or scheduling, et cetera, et cetera. So something along the lines of being able to take different aspects of algorithms and putting them together in the context of an algorithm design or a system design.
Okay, thank you, Vedi, and thank you all. So let's see, how much time do we have left? A few minutes, I believe, maybe 5-6 minutes. Questions for us? And also offer of helping review this. We love to actually get that kind of offer as well. Also, I want to point out is that we would be working on the computer engineering aspects of this TCPP curriculum. That would be the next thing. So we want some volunteers from that angle as well. Those of you who are interested in working on exemplars, course exemplars, or topic exemplars, or even the entire curriculum exemplars, or have worked on those, I think that's another major focus for us.
All right, I suppose if there are no questions coming, then we should move on to the next session, and I'll give the speaker trait to David Brown, who runs the next section.
Okay, so the next section is
there's one or two questions here. Let's see, Anu is here.
Is there a place to sign up to help review?
So Anu, I have you here, and I'll actually send you an email. And there's another question from Suzanne, I believe.
Yes, Suzanne asks, is there any thoughts about adding an importance element?
Can you explain this a little bit? Oh, tier 1, tier 2, okay. Prioritizing. Anybody wants to address that?
We have the Bloom levels. I think that's what comes closest to the importance level at this point.
Yeah, so I think that would be one way to look at it. And also, I think we did talk about various tiers or some priorities. Could be something to take up later on. Right now, I think it has become a little bit more spread out. We are doing the core courses, but also we've added the advanced courses, and that is one kind of division. So Suzanne, if you look at it, you'll probably get a sense of these two areas which maybe you can think of that as a tier 1, tier 2, but there could be more prioritization as well.
I'll also just throw in that it's there's a certain amount of fraughtness with we discussed this, and there's a certain amount of fraughtness with designating certain things as tier 1 or tier 2 because different people feel certain things should clearly be tier 1, whereas other people would say no, that should be tier 2. So that's a difficult thing for a smaller effort to do. It would require a much broader effort to reach some kind of consensus.
Okay, I don't see.
Joel has one question.
Joel has, will this follow the knowledge area approach or make the transition to competencies?
Anybody wants to take this up?
So we've been discussing a transition to competencies, but most of the work was done under the guideline of the knowledge areas from the CS 2013 curriculum. And so that's the way the curriculum is currently cast. But yes, we certainly recognize competencies as another way of organizing it. And we're interested in looking at a future revision that would address that, possibly in cooperation with other efforts that are working on curricula.